An apocalyptic asteroid impact is just one of a number of doomsday scenarios that could wipe out all life on the planet. Now, experts have found that a nuke with the power of 200 Hiroshima bombs would be needed to stop a 650-foot, 200-meter wide space rock from striking the Earth. Russian scientists modeled the explosion necessary to destroy the asteroid by creating miniature models and blasting them with a laser. By scaling up their results, they were able to calculate the force required to obliterate a deadly object on a collision course with our homeworld. Scroll down for video. The finding was made by experts at Rosatom, the Russian state's atomic energy corporation, and 3 physicists from the Moscow Institute of Physics and Technology (MIPT). There are 2 basic options when it comes to protecting the planet from a collision with an asteroid. They either have to be deflected or blown into pieces, most of which will miss us or burn up in the atmosphere. The authors of the paper explored the second option by modeling the effects of a powerful shock wave released by a nuclear explosion on an asteroid's surface. The research team showed that a brief laser pulse aimed at a miniature replica of an asteroid produces destructive effects similar to those of a nuclear explosion on an actual space rock. The distributions of heat and pressure predicted for the real event generally match those measured in the scaled-down experiment. At the moment, there are no asteroid threats, so our team has the time to perfect this technique for use later in preventing a planetary disaster, said study co-author Vladimir Ufa, an associate professor at MIPT, in a written statement. We're also looking into the possibility of deflecting an asteroid without destroying it and hope for international engagement. Asteroids are celestial bodies consisting of carbon, silicon, metal, and sometimes ice. Scientists usually classify objects larger than 3.3 feet, 1 meter, as asteroids. Although this lower limit is disputed, on the other end of the scale, asteroids get as big as 560 miles, 900 kilometers, across, traveling at speeds of up to 12 miles per second, 20 kilometers per second. Such giants pose a threat of obliterating all life on Earth. Currently, NASA would not be able to deflect an asteroid if it were heading for Earth, but it could mitigate the impact and take measures that would protect lives and property. This would include evacuating the impact area and moving key infrastructure. Finding out about the orbit trajectory, size, shape, mass, composition and rotational dynamics would help experts determine the severity of a potential impact. However, the key to mitigating damage is to find any potential threat as early as possible. NASA is currently moving forward with a refrigerator-sized spacecraft capable of preventing asteroids from colliding with Earth. A test with a small, non-threatening asteroid is planned for 2024. This is the first ever mission to demonstrate an asteroid deflection technique for planetary defense. The double asteroid redirection test (DART) would use what is known as a kinetic impactor technique, where striking the asteroid to shift its orbit. The impact would change the speed of a threatening asteroid by a small fraction of its total velocity. But by doing so well before the predicted impact, this small nudge will add up over time to a big shift of the asteroid's path away from Earth. Agencies across the globe have programs in places to map rocks as they move through our solar system. For example, a 100-foot, 30-meter asteroid called 2012 TC4 passed within 27,000 miles, 43,000 kilometers of Antarctica in October 2017. Astronomers describe this distance, which is around 1/8 of the distance of the Moon's 239,000-mile, 384,000 kilometers orbit, as damn close. NASA has previously claimed that the planet is overdue a huge asteroid strike. Professor Stephen Hawkins was among scientists who believe it is only a matter of time before the Earth is destroyed by an asteroid impact similar to the one that killed off the dinosaurs. This is why it is vital that we have measures in place to deal with an asteroid that's on a collision course. If it is detected, for their laser model to be accurate, the researchers made sure the density and rigidity of the small-scale asteroid and even its shape mimicked the real thing. Thanks to this precise correspondence, they were able to directly calculate the required energy on the actual asteroid from the energy of a laser pulse destroying its miniature replica. For example, to eliminate a 657-foot, 200-meter asteroid, the bomb needs to deliver the energy equivalent of 3 megatons of TNT. This was calculated once the team worked out that it took a 500 joule laser pulse to destroy a mod of 0.3 to 0.4 inches 8 to 10 millimeters in diameter. Z-bomber, or king of bombs built by the Soviet Union in 1961, had an energy output of about 58.6 megatons. Compared to the Hiroshima bomb's 15 kilotons, the research team also came up with a technology for manufacturing artificial asteroid material. Its composition corresponds to that of chondrite, or stony meteorites, which account for about 90% of asteroid remains reaching the surface of the Earth. The properties of the model asteroid, including its chemical composition, density, porosity, and rigidity, were adjusted during manufacturing. The replicas were made using the data obtained from the chondrite meteorite recovered from the bottom of Lake Chebakul. This was the largest fragment of the asteroid that entered the Earth's atmosphere in February 2013, exploding over Chelyabinsk Oblast, Russia. In some of the experiments, the laser was targeted at a cavity made in the miniature asteroids ahead of time. Experts found that a buried nuclear bomb would be more powerful than one on the surface. The research team plans to expand the study by experimenting with asteroids made of different materials, including iron, nickel, and ice. They also intend to identify how the shape of the asteroid and the presence of cavities on its surface affect its destruction. The full results of the study were published in the Journal of Experimental and Theoretical Physics. Researchers have discovered most of the asteroids that are about a kilometer in size, but are now on the hunt for those that are about 140 m, as they could cause catastrophic damage. Although nobody knows when the next big impact will occur, scientists have found themselves under pressure to predict and intercept its arrival. Sooner or later we will get a minor or major impact, said Rolf Denzing, who heads the European Space Operations Centre (ESOC) in Darmstadt, ahead of International Asteroid Day on Friday. It may not happen in our lifetime, he said, but the risk that Earth will get hit in a devastating event one day is very high. For now, there is little we can do. And yet, the first ever mission to crash a probe into a small space rock to alter its trajectory suffered a major setback when European ministers declined in December to fund part of the project. We are not ready to defend ourselves against an Earth-bound object, said Denzing. We have no active planetary defense measures. Source: AFP.
Where the freaks at?